Yeah, thank you very much for the introduction. So optimizing software-defined value streams. So what are we talking about the next 20 minutes? Hopefully you do not expect the solution or the perfect software company. We did not prepare that. And I'm sure there are people inside this audience who know that much better than us. And there are a lot of presentations about this. So what we want to focus is the change, how to lead the change, coming from a hardware-defined product development to a software-defined product development process.
And I would like to start here with one of the assumptions that we have had in the industry. You can see here it's titled with yesterday. And that was that there is a tight coupling between the software and the hardware at the point of delivery. At the start of production, the software is flashed. And this assumption, now going forward to software-defined vehicles, has to be reworked. And that is a change process indeed. And in the beginning now, I will try to shed some light on what this assumption means, or what a natural way to organize an organization under this assumption might look like. And maybe some of you have see some familiarities with your organizations that you're working in. So in our automotive industry, speaking now for tier 1 supplier, we're very heavily working towards satisfying the customers, the OEM needs, and that naturally creates a certain set of variants. And we're setting up for that customer teams that support these variants and customer solutions. But not all of them are entirely different, right? And it's titled here as well, maximum reuse. Yeah? Under the assumption of a coupling between hardware and software, this is a key driver. So what are we doing? We're creating some common part. We're isolating it. We put it into, say, something like an integration platform. The term can vary, but the core concept here is put something together that is shared to a very large degree among multiple customer solutions and develop that in an own organization structure in a department or even bigger. And then you can see on the bottom, you have an on-demand integration. So the customer solution requires some functionality, and the certain version of the integration platform can satisfy that. So that's sufficient for that project context where you have a certain SOP at a certain point in time. And because one can go a step further and one can optimize this, we can even, of course, go one step further and we can have software components, also again, the term can vary, that are shared among multiple integration platforms. And then we end up with something like a delivery chain already inside an organization like the one that we're coming from. And this is also, I would like to ask you to keep this picture a little bit in mind for what is going to come. This is something that we say now, in also referring to our experience from production. It's like a value stream. It's a delivery chain. Internally, there's handover points. And you can see that here nicely illustrated by the versions that I put here as examples. So you can see that there is a software component. It's, let's say, the latest version. And a slightly older version is part of this integration platform at this point in time. And even some slightly older versions are the ones that are at the moment in a customer project context. And this is really effective by maximizing reuse of software components in the sense of how much of the artifacts that are going alongside with this, we all know it's not only code, is reusable in the sense that it can be, I overstate this a little bit, copied and owned in the customer project. And because that is the case, it's copied and owned, there's also some flexibility in the sense that if it doesn't fit right away, there are going to be some modifications to that. And we call this here patches. It has also emotionally like slightly negative connotation, yeah? And that's also intended a little bit, because as we now go forward, so with these patches, with these modifications, let's say divergence in the code base, that, for example, the software component team doesn't necessarily know about how they're done in a specific customer version. And now going forward, what is the challenge here? If I want to update all of this, if I want to have a pass-through on this value stream, if I want to update to the latest version of the software component in this customer solution, then there's chance for conflict, because this software component had been changed by the team of the customer. And this is, yeah, it can break the integration at a certain point. And this is where we come then in the future, and where we see, okay, at this point, we have to rework our assumptions, and that leads to also some maybe rework, and also how this organization needs to perform. And here we have then decoupling in the software-defined vehicle. So we want to continuously be able to deploy new versions into the field on a hardware that was shipped with some older versions at the SOP. And now I think we will go over to how we can make it from yesterday to tomorrow. And maybe I think everybody is in a little bit somewhere in the transition.
So, in 10 minutes. So how do we lead that change? We have the old world, we have the new world. One thing will not work, this is clear, if we now make everything different. So we have to bring the new ideas from the younger colleagues in the world we already know. Yeah? And to make that transparent, what is really the problem we do have, the first step you have to do is a value stream analysis. So this is commonly known from hardware production and shows really the problem we do have, what Felix already stated, with different diverging code bases. So what you can see here, this is just an example for an integration platform. We do have a lot of red dots in that chain. So red means this is no value add. You could also say this is pure waste. So the yellow ones, this is necessary, has also no value add, but okay, I have to do a test. And only the green ones really make some value add. And what you can see is the most effort we do have is the integration. This is pure waste. And this is because the code bases are different. Everybody has different reference systems. So what worked in hardware production is very difficult in software production. So what can we do against that? So I think the most important thing is to baseline an architecture, to clean up the code and to come to a common architecture where I do have the capability to handle variance, because in our business case, we do have variance. The best would be to have no variance, like Tesla, only one car and one sensor set and so on. But we do have variance. So we need a software architecture which is capable to handle the variance with service variance, with stable interfaces, not with patches like Felix showed. Because then we do have code divergence, and this leads to other patches, and this is a vicious circle. So the first is you have to align the architecture for your common code base. The second point is process, methods, and tools. I think one thing is clear. If you come from a company, decades of hardware development, the most processes relate to hardware development. So you have to change, you have to rethink which processes can be used and which makes no sense or hinder the software production on that point. This is only one thing I want to focus on, but there are a lot of more topics. It's the releases, the quality gates. I think we all know that from past time. We had a development phase of 3 to 5 years, and there were 4 prototype stages where you make something like releases. But, well, in software development, this is a little bit different. You do have a main path which also always have to be releasable. Yeah? And of course, you do have feature branches where new features are developed. And then comes the point when the teams want to go back, want to merge their feature development to the main path. And at that point, you have to fulfill the quality gates. So a lot of tests are done if hundreds of developers are working in parallel on a common code base. So you need automated tests, not manual tests, that have to be triggered automatically. And yeah, you can see here some examples. I think you all know compiler, QRC, Kuverty, and so on and so on. And of course, functional tests, functional suitability. And this comes to that point here. You need a way how you can rid of your hardware dependencies. If you have hardware-related tests in that chain, that makes you extremely slow. So you need a data model which gives you the capability to virtualize such smoke tests, that you can run such a software cycle with a proper lead time. So if you are there, I think a lot of is done, but unfortunately, a common code base is still not sustainably anchored, because there's one point we did not address so far. It's the organization. And I think we all know Conway's Law, 1968, organizations which design systems are constrained to produce designs which are copies of the communication structure of these organizations. So what happens often is what is depicted here. We do have a component developed division, we do have a platform developed division, and we do have customer solutions. And this is a separation of concerns, which we will have always. But if I do have separated teams who have their separation in tasks, then you will also get a separation in the repositories, a separation in the codes. Everybody will clone the code bases, and you will never get a common code base. So what you have to do is, even if you have verticals which are separated, you have to bring the competence centers, the horizontals, together. For example, there's one perception team from driver assistance systems coming, which is responsible for the new functions, for the new algorithms, but also for the integration in the platform code, which is directly related to the customer solution. Last but not least, every process has to be inspected and adapted, so this is a continuous improved process. What we learned from past, from hardware development, we need KPIs by which we control that. Daily, automatically evaluated, and of course, if something that we do have findings, something does not develop in the way it should, then we need forensic, we need a root cause analysis. And here we need a capability. In past time, we would have said, go to Gemba, the Gemba walk, so the leader shall go down to the factory, to the place where it really happens. In software, this is really difficult, and here helps Serene, because Serene gives us the capability for the management to go down to the code base and to see where I do have the QRC warnings, where I do have a lot of changes in the code, and so on and so on.
So now if you recall the picture, like the value stream, the delivery chain that we saw in the beginning, now how can we work towards this new way, let's say, of continuously integrating along the whole chain? It cannot be a greenfield approach. That goes just way against the principles here. It needs to be evolutionary. So how can we bring closer together the structure, the organization, and what we see here, and I think many of you know them and with the gray background, are accelerate KPIs, 4 KPIs that quantify, we think, nicely also how let's say productive, how service oriented, also some like a part in this value chain is with respect to the part that is taking, that is integrating still this component. And I want to first speak briefly about deployment frequency and integration lead time, because they go together. In the picture of the factory, you can think, okay, at the end, so how many parts fall off? Yeah, so what is the output, if you want to say? Deployment frequency, so how often am I actually deploying new features, bug fixes, updates in general at a customer solution here? But this also holds true if I have a longer chain. Yeah, it's just one example. So how often do I deploy? And Matthias showed it with the value stream analysis. One very important determinant of that is what we have identified there, integration lead time, yeah, especially that one. So if I want to deploy more frequently and the integration is very painful because there's so many divergences, as we saw previously with patches, I want to avoid that. I want to do that less often. If I can bring the integration lead time down, with that the effort down, it goes easier, I can deploy more frequently, and these two metrics can improve. But this is only one side of the story, right? Because if I deploy something and it breaks at the place where I deploy it, that's not a situation we want to be in. Yeah? So there's also, like from this throughput, also in parallel to how the thinking goes in production, there is a set of quality-related aspects, quality KPIs, and what is capturing here, change fail rate, is exactly this. So there's a large set, let's say maybe in the beginning an initial set, but in the full-blown system, a large set of acceptance tests that are actually all the tests that make a customer solution confident to integrate a new version. So when do I know that this is going to work in my case? I run these tests. If they are succeeding, then I'm confident to integrate. And this step, these automated acceptance tests, we're introducing here at the handover points in this value stream. And of course, maybe not always they will be succeeding, and in the case they fail, then also mean time to repair is the measure that lets us know how quickly are we able to recover from that. And in its entirety, like playing together, these KPIs give a good indication of how good the handover in this value stream is working. Of course, you can apply them inside the boxes that you see here, the blue boxes as well. There's also QGs, there are also tests. Everything is there. This is probably advisable, but especially on the value stream, and that we mean instrumenting all the handover points with these metrics and steering, making use of that also as a tool for steering. And then in a target setting, it's actually not a new term, yeah. So continuous integration, but this time not in a project setting, but on the entire value stream. Yeah. It doesn't necessarily mean that there's one repository. It can be multiple repositories, but I have to make sure that I integrate alongside these continuously. And we saw patches, and that's also where we want to say. We're making use of Serene here also to display that, also to be able to identify early in case there are patches coming up in certain value streams. That being one value stream, we have many of those. We can see, okay, for a certain component in a certain customer context, patches are introduced, and then the component team can get directly into contact, and the issue can be solved. So why actually is there a need for a patch? And that being just one example of how we can make use of Serene for making this Gemba walk possible. Of course, some developers might also be able to extract this information from the Git or from the versioning system. That's also how we get to the information. But making that communicable, making that, presenting that in a way that one can discuss about that over multiple hierarchies, we see that there's good use for tools such as Serene for that.
I think there is a very essential point which Felix stated out. It's not the project in itself. They can optimize them. They do have KPIs. It's the handover point. Is that the same what we learned from hardware production? The the handover from one line to the other, there I do have the problems. And this is what we talk about, not to optimize certain projects, to optimize the entire value chain for the whole product or the product class. Yeah? And there is another aspect. If we want to be successful in that change, we have to bring the success factors of a company from the past together with the new ideas. If I just come with new ideas, I will also fail. And a very important aspect is to connect your KPIs, which are important for your software development, to the business value. If you do not, then they will steer you like a hardware production and you will also fail. So this is just one idea or one example how you can do that. And this is mirrored to that what we know from hardware production. So this is a Kpi tree with different levels. Result KPI is the productivity, which can directly connect it to a business value. And of course, on the monitoring KPI side, which directly contributes to the productivity, is the deployment frequency or the output of a factory. On the other side, the quality side, the change failure rate. In past time, would have said the first pass yield. Yeah? And then this is, I think, a very good point or a very good thing what these guys developed in past with hardware production improvement KPIs. That are KPIs, they are important for the teams. So maybe they do not know how to change the monitoring KPIs, but what they can do, they can improve their improvement KPIs, which are on the levels of the teams. And this is production lead time, this is feedback time, this is number of patches. This can take every developer in his own end and improve. On the other side, on the quality side, we do have the mean time to repair. This is important for every developer. Static code analysis, which just has to be done, and functional suitability. In our cases, this is, for example, object losses, yeah, as a technical KPI to optimize algorithms in perception. So coming to the end, summarizing, I want just to give you some key takeaways at the end of the presentation. So business value is only created by continuous deliveries towards the paying customer. That means avoid internal deliveries because that make a lot of effort and makes no value to the customer. Variant handling in software architecture is crucial for minimal production lead time and maximal reuse if you are in a business case where you have a lot of variations. Inspect and adapt the engineering process based on productivity KPIs and root cause analysis. So the Gemba walk. And last but not least, engineering organization is deployed along architectural components with common targets and accountability. And the first part of the sentence is always true. So the better you shape your organization in a way that it makes sense for your architecture, because this will always happen, what is printed here. Thank you.